Hello, today I'm going to show you how I built a functional mech in Minecraft Create mod. And this is how I built. Let's jump right in. The best way to start any project is with a plan, and I came up with few key requirements for my mech. First, it should look like a real mech and move on two legs. Second, it should rotate naturally, not just with 90-degree rotation. Third, it should have a control room where I can, you don't believe that, control the mech. And the last one, of course, it should able to shoot.
Anyway, I started blasting. Bang! Bang!
And I saw that was more than enough for the first version. Yeah, there will definitely be updates in the future. Alright, first thing first, the mech need legs, and not just decorative ones, but ones that actually move with physics. And before getting into anything complicated, we should start simple. So what's the simplest one? A rigid leg, like a single bone. By the way, if you're not familiar with the add-ons for create mods that I use here, it's called Clockwork. To begin with, I used a physical infuser and those made an object with physics. Now it's affected by gravity. Then I added a leg using a physics bearing and connected them with vertical gearbox. By using a gear shift and giving redstone signal at a certain interval, I was able to make my legs move in different directions. The redstone interval signal is made by a connected to pulse repeater, and using a toggle latch I can control the gear shift. Now let's see if it can move. And to keep it from falling, we need a gyroscope for stabilization. And since the legs are attached by physics bearings, each leg requires its own gyro. And just like that, it works. And that was a rigid leg with a single bone. Now we need to add a second bone to allow it to bend. Just like before, we will add a second bone using a physics bearing and give it a gyroscope. Well, it moves, but leg bends way too far back, and that's definitely not how legs are supposed to work. Which means we have to restrict how much the second bone can bend. I tried many methods, but most of them didn't work the way I wanted. And I even got this. But in the end, I find a solution. Instead of making the physics bearing in the end or below of the first bone, it needs to continue, and the second bone should wrap around first one like this. Of course, do not forget about gyroscope, and we got this. It's a little bit slow. Let's increase our rotational force and test it again.
Yeet? What's a yeet?
Yeet!
Now it's looking pretty realistic, but what if we go even further and add a third one, like an ankle? I used the same method as before, and look! We finished the prototype legs, and I'm happy with the result. Next, I needed to make sure that it could rotate smoothly, not just snap to 90 degrees. When I started working on this, I had no idea how to make it perform as intended. My first idea was to make the legs rotate around an axis, but then I ran into a problem. How do I turn the body in the direction of movement after turning the leg, if I can even turn the leg at all? That made me abandon this plan right away. My second idea was to rotate using propellers. The plan was to position them diagonally on opposite sides so they would pull in different directions, creating a turning motion. But first, even if it worked, it would look ugly. And second, as I found out, the method only works well when the physical object is long enough and relatively light. This means I would have to use giant propellers. That's why I also gave up on this idea. For my third idea, well, I didn't really have one. I just started experimenting with bearings, tinkering with them in the hopes that I would figure something out along the way. At some point I had this crazy thought, what if I just rotate the base using physical bearings? I knew it wouldn't work because it would need some kind of pivot to function properly, but I went ahead and tried it anyway since I had no other options. And I got this, but it didn't work either. The attached block with physical bearings didn't have enough weight.
Wait a minute!
When I tried to place the iron block, I noticed a slight bend. That's when I decided to test it again, but this time properly. Once again, I built a simple rigid leg and attached gyroscope to it, but it didn't work. But wait, maybe the problem was the gyroscope at the base for stabilization, which prevented it from rotating. If I just place the gyroscope on an iron block, it should work. And finally, it works. Now we can turn left and right. If only you knew how much time I've spent figuring this out. Oof. Now, let's integrate this into the legs we've been working on. Here, we will add the clutch and the gear shift to control the rotation. We're also adding more iron blocks to these legs, but be careful not to overload them, or they might glitch. Let's adjust the rotation force of the legs to prevent them from falling, and look at this. We are able to rotate. Also, it's compact enough to be hidden easily, so let's move on the next step, creating a controller. Everything is working so far, but now we need remote control, and for that we will use the link controller. It's pretty simple. Press the top button to move forward and the left or right button to turn. But also we need to make sure that everything works smoothly when pressing multiple buttons at once. So let's set it up. To move forward, we need to control the clutch at the base. When clutch gets a redstone signal, it stops the rotation force. So, by default it should have redstone power, but when we press the top button, it should turn off and let the mech move forward. For this, I can use the latch and the link. The latch has two inputs and one output. One input is for power and the other is for reset. Don't confuse it with the toggle latch, which I used here. A toggle latch simply switches the output signal with each external signal. So I will set one input with constant redstone signal, while the other will be controlled by a link. This link will be connected to the top button of the linked controller, and the latch output will be connected to the clutch. Now we have full control over moving forward. Next, we need to set up turning. The logic is almost the same, except that one of the links should activate the gear shift to rotate in the opposite direction. And that's all about control, and let's test it. Let's add some more iron blocks to spin faster and adjust rotation force. And that's how it all works together. The mech can turn even while moving forward. And that's it. That's how I built. I've shown you all the basic techniques for creating this mech. The next challenge came when I started decorating it and trying to make it more realistic, but I'll cover that in the upcoming episodes. I will also try building its survival mode. Well, maybe not full survival, but I will show you how it could be built in survival. I hope you enjoyed the video, and if you try making your own mech, maybe you will come up with better solutions. Share your thoughts and ideas in the comments below, and if you want to see more crazy builds like that, make sure to subscribe. See you soon! If you have some free time, you can check out my first video. I have no idea why I made it, but I did.